All right, in this video, I'm going to be working some extra practice problems for 6.3. That's going to be more U-Substitution. And it's this practice set that's got a couple of differential equations and some graph table scenarios. These are really just some things that didn't really appear on the normal 6.3 homework that you still probably should be aware of for this class. All right, so let's get to it. Let's do some separation of variables. Find y equals f of x, the particular solution to the given differential equation with the given initial condition. That's the code word for do separation of variables. Okay, but this doesn't look separable, right? I need to factor it so it does look separable. So I'm going to factor out an x, and I'll be left with a 1 minus 4y. And that's dy dx. Okay. And so now I can start getting towards separation of variables. I'm going to divide both sides by 1 minus 4y. And then I'll have an x dx over here. And if these two things are equal, their antiderivatives will be equal. And so this is kind of a linear inside. This is going to have log absolute value of 1 minus 4y. And then I'm going to have to divide by the slope of the inside, which I guess is right here. And that's going to be divided by negative 4. So negative 1/4 equals 1/2 x squared plus c. Okay. Now I'm going to start trying to get at that y, and I'm not sure I'm going to have quite enough room on this page, but I'm going to try the best I can. Log absolute value 1 minus 4y equals, multiplying by negative 4, that would be negative 2x squared plus c. And now I'm going to take e to both sides power. I'm going to get absolute value of 1 minus 4y equals c e to the negative 2x squared. Kind of giving up hope on fitting this all in. I'm going to just grab a Post-it note or something. And then I'll drop the absolute values, and I'll get 1 minus 4y equals plus or minus c e to the negative 2x squared. Then negative 4y equals negative 1 plus or minus c e to the negative 2x squared. That's about as far as I can get. I'm going to start writing on the next set of problems. Right, let's just keep this going. Okay, divide both sides by negative 4, and I'll get y equals negative 1 divided by negative 4 is positive 1/4. That's still going to be plus or minus some other c now, e to the negative 2x squared. Okay, and yeah, now I've got y. Now I'm ready to kind of try to figure out what my value of c is using the initial condition. You can't see it up there, but f of 0 is negative 2. So y equals negative 2 when x equals 0. So 1/4 minus something, e to the 0. All right, so I'm going to say negative c is negative 2 1/4, so c is 2.25, but I can do a little bit better than that. I can say that's 9/4, because that negative 2 is negative 8/4. All right, so c is 9/4, and I am subtracting. And so my equation for f of x, or y, you can either write y equals and then write f of x, or you can just write f of x equals, whichever you like. So I'm going to say that y is equal to 1/4 minus 9/4 e to the negative 2x squared. Okay? And really the thing that made this, fit in with today's lesson, the U-Substitution, is that little bit right here. That's this step right here. That's the 6.3 thing. Okay? But definitely, be aware that we can use U-Substitution and other guys just, hey, here's an integral computed, right? We've used these integrals for some things so far, and we're going to use them for some other things, and the U-Substitution will continue to come back every once in a while. Okay, now I'm going to separate variables, and it's like, okay, here's the y, so I need to just, really everything's connected with multiplication, it's fully separable, so I need to divide both sides by y, so I've got 1 over y squared is y to the negative 2 dy is going to be, and then I'm left with a 4 and an x and a cosine of x squared. Now, you can divide the 4 over there, but it's just going to make your life more difficult. I don't recommend it at all, and but yeah, I mean, you can, and you'll end up with the same answer. Okay, but I'm going to keep the 4 with the x because it'll make my U-Substitution a little easier over here, right? I've got a product, and I can't do anything algebraic to it, so at this point in the course, it's got to be U-Substitution. Okay, and so I'm going to probably let u equal x squared, du is going to be 2x dx, so I've got 4x, so who knows what I'm going to do there. All right, let's anti-differentiate. This would be negative y to the negative 1 equaling, okay, I forgot I'm going to need to do some U-substitution work up here maybe. Maybe I will put it down like that. Yeah, that will work. All right, so I'm going to do my U-substitution over here, and I'm going to say, I'm going to let u equal x squared. Still, yep, I'm still visible. U equals x squared, so du dx equals 2x, and du is 2x dx. Okay. So I could say, I think what I'd like to do is multiply both sides by 2 and say 2 du equals 4x dx, because that's what I've got right here. So I'm going to try to match that up perfectly. And I'm going to get antiderivative of, well, cosine of u times 2 du, so 2 cosine u du. Okay. And I anti-differentiated over here, but I realized I wasn't quite ready on the right side, right? I had to do my U-substitution. So an antiderivative for 2 cosine of u with respect to u is going to be 2 sine of u. But we know that u is equal to x squared, so I'm going to do that. And I'm not going to forget my plus c. Okay, now I'm going to start getting at this by multiplying by negative 1. And then y to the negative 1 is 1 over y. So if I wanted to get at y, I was going to just flip both sides of the equation. Okay. Now that I've got an expression for y, I'm going to go in and compute my value of c. When I plug in x equals 0, I get y equals 3. So 3 equals 1 over 2 times the sine of 0, so negative 2 times the sine of 0. Sine of 0 is 0. In case you didn't believe me, right? That's theta equals 0. Sine of theta is the y-coordinate on this drawing, that's 0. So 0 plus c, that tells me that c needs to equal 1/3. And then my solution is y equals 1 over negative 2 sine of x squared plus 1/3. And that was some good separation of variables. All right, use the graph of g and the table of values for f to evaluate these integrals. And I know that this is going to be a little crammed, so I'm going to zoom in and use a thinner pen. All right, this one I'm going to just find an antiderivative for f double prime of 2x plus 5. It's going to be related to f prime of 2x, but I'm going to have to divide by 2 to prepare for the chain rule. And then the antiderivative of 5 with respect to x is going to be 5x. I'll plug in 1 and 3, and I'll get, okay, this is going to be equal to 1/2 f prime of 6, because when I plug in 2 times 3, plus 5 times 3 is 15, minus, I'll plug in 1 for x, and I'll get 1/2 f prime of 2 plus 5. And then half of f prime of 6 is going to be 0.2, so 15.2 minus half of f prime of 2 is going to be 0.25, so minus 5.25, and I think that's going to be 995, but let's just not. Let's just leave it like that. This one, f prime of x times e to the f of x. Okay, that's cool. Well, it's interesting. It's different. It's something we haven't seen yet. That's why I put it on the problems. I don't think it's definitely not going to be something that's like on the quiz next time, but I could. This is something that I used a lot last year when everything was online. Was I would use a table or a graph, and I would put U-substitution like this, and all of a sudden it made it much more cheat-proof. You know what I'm saying? So I'm going to let u equal f of x, because then du will be f prime of x dx, right? And this looks like, and it's going to be something I'm going to be able to anti-differentiate. It is going to be a perfect match, so I'm going to go up here. I'm going to say u equals f of x. still some more room. So that du equals f prime of x dx, which is exactly what I have, so that's a good sign. And when x equals 2, u equals f of 2, that's 0.9, I am realizing, oh, no, it's still going to be all right. Okay. These can be a little touchy. You have to get them set up just right. But you'll see, you'll be like, oh, man, you don't have anything for x equals 0.9 in here for f, but up in this table, but it doesn't really matter because it's just going to be e to the u. So when x equals 6, u is f of 6 is going to be 1.8. Yes, okay, that's a good problem. All right, so this is now an integral from 0.9 to 1.8 of e to the u. F prime of x dx is du. And that's e to the u as u runs from 0.9 to 1.8. And so we'll be able to do this. This will be e to the 1.8 minus e to the 0.9. You know, if this was last year, I'd have had you throw this into a calculator and type your answer into a computer so I could tell you if you were right or wrong. And this is the type of thing that otherwise you wouldn't be able to throw into a calculator except for at this last step, or maybe actually at this step also, was I think what a lot of people were doing. But you actually had to do the U-substitution by hand. So it makes this kind of a good problem and something you should be aware of. I've got a couple more like this. So integral from 0 to 3 of g prime of 2x. Okay, oh, and then I'm going to do number 5 and then number 7 immediately after to just kind of contrast them, because they're both kind of interesting. Right, this one's going to be straightforward enough. It's just going to be one of those minor chain rule inconveniences where I have to divide by the slope of the inside. So an antiderivative is going to be g of 2x divided by 2 for the chain rule. Because if I take the derivative, I'm going to get 1/2 g prime, leave the inside the same, so I'll have 1/2 g prime of 2x multiplied by 2 for the chain rule is that 1 g prime of 2x that's in my integrand. So this is 1/2 g of 6 minus 1/2 g of 0, or you could factor out the halves and say it's half of g of 6 minus g of 0. I think that's 3, 4, 5, 6, g of 6 is 0. So minus half of g of 0 is 3. You cannot see that, but I was saying, pardon me, I was saying g of 6 is 0. So that's 6. And this is 0, and g of 0 is 3. That's why I'm getting those. So that's negative 3/2. Okay. To contrast, this one's going to be pretty similar. I'm going to anti-differentiate to get g prime. I'm going to leave the inside the same. Whoops. Didn't leave the inside the same, though. I'm going to leave the inside the same, and I'm going to divide by the slope of the inside. So that'll be divided by half, which is multiplying by 2. Then I'm going to plug in 2 and 6, and I'm going to get 2 times g prime of 6 divided by 2 is 3, minus 2 times g prime of half of 2 is 1. Now I'm going to have to go and figure out what is the slope of g at 1 and 3. To make this happen. And so that makes this a good problem, right? Because you have to integrate and remember that the derivative represents the slope. Okay, so at here where x equals 1 and where x equals 3, I need to know these slopes. So this is a line with slope negative 3. Okay, so I'm just going to plug in negative 3 for g prime of 1. And then over here at g prime of 3, the slope is positive 3. So I'm going to say that that is 3. And then I'm still multiplying these by 2 and subtracting, but that'll be 6 plus 6 is 12. Right. All right. This one, I'm going to have to rewrite this as, but actually I can see that it's going to be, I've got a perfect match. I'm going to let u equals g of x, so du is g prime of x dx, which happens to be exactly what I have right here. So this will be good. This will be 1 over the cubed root of u, which is u to the negative 1/3 power. Now I just need to convert my x's to u's, so x equals 2 means that u is equal to g of x is -1, -2, -3. And that's why I had to do the cubed root. Yeah, I initially made this square root and I realized it wasn't going to work. Okay. And then at x equals 4, that gives me u equals 3. So I'm going to go from -3 to 3 now. Equals the integral from -3 to 3 of du divided by the cubed root of u. So that's du over u to the 1/3 is the same as u to the negative 1/3 du. Okay, we're going to add 1 to the power, so negative 1/3 plus 3/3 is 2/3. Divide by the 2/3. Okay, we don't know a cubed root for 3, so we're not going to be able to actually, compute these exact, or, well, simplify them, I think is what I should say, because we won't be able to compute exactly. That'll be 3/2 of 3 to the 2/3 minus -3 to the 2/3. And -3 to the 2/3 is a well-defined number. It's a real number because we can take cube roots of negative numbers. Just don't forget that. And that's going to be an exact value of my integral there. All right, here we have u prime divided by u, which I feel like is a good place for us to stop, probably. Okay, I'm going to let u equal f of x. So that du is f prime of x dx, which happens to be exactly what I have, so that's a good thing. And, okay, I need to go, okay, x equals 1 gives u equaling f of 1. F of 1, I'll just tell you from the table, is 0.4. And x equaling 6 gives u equaling f of 6 is 1.8. All right, so this becomes, now, I'm going to fold this paper so it's not so low in my shot. Okay, yeah, so I can move it up a little bit. Yeah, there we go. More room to work. And you can see it. So this is going to be the integral 0.4 to 1.8 of 1 over u du. So that will be log of the absolute value of u as u runs from 0.4 to 1.8. So that's going to be the log of 1.8 minus the log of 0.4. And that's going to be all I've got for you in this set of practice problems. This was a good one. These were different from the algebraic examples, and these problems could definitely come back in the future.